Hi everyone, this is Rukafle. Today I'm gonna show you Lab 2B soil classification, specifically plasticity and Atterberg limit tests. The question is, why do we need to conduct Atterberg limit tests? Now, these Atterberg limit tests are conducted to define or to determine the plastic nature of fine-grained soils, which are clays and silts. Clays show naturally higher plasticity, while silts show slight plasticity or no plasticity. So this is one way of identifying whether that soil is clay naturally or silt. So in today's test, we conduct 3 small tests. The first one is determination of water content. The second one is determination of plastic limit. And the third one is determination of liquid limit. So before we go into the testing, let's have a small theoretical background about the Atterberg limit tests. As you know, soil can be in a state of solid, semi-solid, or it can be in plastic state or in liquid state. This is due to the interaction of the soil with water. As water content goes up from 0 to the extreme value, then the state of the soil changes from the solid to an extreme of liquid. When we start from the liquid, when you say soil is in liquid state, that means the soil and the water are in suspension. Then with reduction in water content, it will reach to a limit where the soil shows no further liquid behavior. So that boundary is liquid limit. Upon further reduction, there will be a range that the soil shows a plastic nature. That means it shows a deformable or remoldable nature. And that is what we call the plastic state. And with further reduction in water content, it will reach to a limit where it doesn't show any further plastic nature. That water content is called the plastic limit. Here we have one important parameter which is called plasticity index, which is the water's range at which the soil status shows the plastic nature. So with further reduction, we reach to a point or a boundary where the soil shows no further reduction in volume. That is called the shrinkage limit. The first part of our test will be the soil description and determination of natural water content. Here we have the soil sample, which is the block of clay, and from this we take out 30 grams of soil, this one, and then first we need to have a moisture can. We need to measure it first and then record it. It is around 30.55, and then we put our sample. Then we take the measure of both the can and together, so we'll have 60.40. After this, we take this one and we put it into the drying oven. Here we have, and we put it here, and we keep it for 24 hours. And after that, we assume that within 24 hours all the water is removed out. So what we have will be only the mass, the container, or which is a moisture can, and the dry soil. So once after 24 hours, we record it here with the mass of the can plus the dry soil. And once we have that, there is a procedure of calculating the water content, which is the water content is basically defined as weight of water removed divided by weight of the solid. And it's mostly expressed in terms of percentage, so it will be 100%. So based on this calculation, you'll come to determine the natural water content of the soil. So this is the second part of our test, which is liquid limit. And for this, we need the basic devices. This one is Casa Grande liquid limit device. We have spatula here. We have grooving tool. We have a ceramic bowl. We have the measuring can, water, and the soil sample. So for this test, we need about 150 grams of soil. And once we measure 150 grams, we put it into the ceramic bowl. For this demonstration, I have already prepared a paste. So what you need to do is, after you put the soil sample, the measured soil sample, into the ceramic bowl, you add water until it forms a paste. But make sure that the paste should not be too fluidy, or it should not be very hard. So it should be a kind of workable paste, as you might see something like this. So once you do that, you put this into a liquid limit device. So when you do this, you trim it with a spatula. You create a level surface with the spatula, as you might see. Make sure that you create a very beautiful leveled surface, and the way you control how much paste you add on it is the depth should not be greater than 1/2 of an inch. So it should not be too much and it should not be too thin. Then after that, you have a growing tool, and at the center of the paste you make a notch. As you can see, I have created a notch at the center using this grooving tool. So the next step will be to turn this crank twice in a second until you get, and you count the number of blows, and you do this until you get half inch of the notch closed. As you can see here, about half inch of the paste is already closed. So once we get that, we need to take out a sample along the side of the closed paste. Once, sorry, once you take out the sample, then make sure that you first measure the weight of the moisture can, and you take also the weight of both the sample and the moisture can. Once you do that, you put it into the oven for the moisture content determination, or for water content determination. So after this, what you do is you just remove this sample, and put it back into the ceramic bowl, and you add some water, and you mix it well. And you repeat this test. So this way, you have to do at least 3 samples. That means with different water content, and you record the number of blows, and after 24 hours, you'll determine the water content. Well, when you are conducting this test, make sure that you record your number of blow counters, and the water content will be determined after 24 hours. So you'll plot it with number of blows in the x-axis. It should be in the log scale, and the water content in the vertical axis. So from this plot, the liquid limit is the corresponding water content for the number of 425 number of blow counters. So when you record the number of blow counters, make sure that it should not be less than 5 or greater than 50. If your number of blows counters is less than 5, that means your paste is too fluidy. And if it is more than, your number of counters is more than 50, that means it is too hard. So make sure that your number of blow counters is between 5 and 50. So our today's third and last test is on the determination of plastic limit. It is very easy test. We need a glass plate, this one. We need a moisture can, because at last we determine the moisture content or the water content, and we need about 30 grams of our soil sample to be tested for plastic limit. So what you do is, once you have this one, you start rolling it on the glass plate. Like this. So you keep on forming a uniform thread. So it will get long and long and long. So you do this uniformly over the whole area, and it gets thinner and thinner and thinner. And once you do that, you'll find at last that it will start to crumble at about 3 millimeter or 1/8 of an inch. If it doesn't crumble at 1/8 inch of the 1/8 inch, then you collect it again and place it over the surface, and you have to wait until it gets drier. But if it crumbles around 1/8 of an inch, then as you might see, it gets crumbled, and you keep on doing this to other parts. As you might see, this is almost 1/8 of an inch. So what you do is you collect a thread having a diameter of 1/8 of an inch, and you put it into a pre-weighed moisture can, and you put it, and then you take it to, you put it to the oven dryer. So you do this 3 times and you record it. The moisture content or the water content that you determined from the 3 samples will give you an average moisture content or water content, which is called the plastic limit.